Hi everyone. In this lecture, we are going to learn about slope detector. In module 6, we are going to discuss about different angle demodulation circuit. Slope detector is one of the simplest FM demodulators. The function of an FM demodulator is to detect the message signal from the FM wave. That means we have an FM wave. The circuit will detect the message signal. That means it demodulates the message signal from the FM wave. The slope detector has basically two building blocks. The first one is the frequency selective network and the second one is the AM detector. So an FM wave is given as an input to the frequency selective network. The output of the frequency selective network is an amplitude modulated FM wave. That means it converts the FM input to an amplitude modulated wave. That means the output will be a mixture of AM and FM. Okay, and this output is given to the AM detector. That means we have already studied different AM detector circuit. One of the AM detectors can be used as a detector here. So the AM detector will demodulate the message signal from the mixture of amplitude modulator FM. So this is the basic block of slope detector. So now we are going to discuss about the circuit of a slope detector. So here is the circuit diagram of a simple slope detector. So I have explained in the block diagram which has two parts. The first one is the frequency selective network and second one is the amplitude detector. So here we are using a tank circuit. So this is a tank circuit used here which acts as a frequency selective network and which is followed by the envelope detector or amplitude detector circuit. So this tank circuit is tuned in such a way that the resonance frequency, that is F0, the resonance frequency of a tank circuit is F0, which is greater than the incoming signal frequency FC. So FC is the incoming signal frequency and F0 is the tuned frequency. That means the resonance frequency of the tuned circuit. So that will be chosen in such a way that F0 must be greater than FC. So by fixing F0 greater than FC, we can have, that means by fixing this F0 greater than FC, the circuit, we are making the circuit to receive the signal on the slope of the response curve. So we are discussing about that response curve. So by fixing in that in this way, so the signal will receive that signal on the slope of the response curve. That is why we are calling this circuit as slope detector. So I have already said this is the frequency selective network. The output of the frequency selective network will be a mixture of FM and AM. Okay. So this is given to the envelope detector. The diode and resistor and capacitors form an envelope detector. So actually this will demodulate the message signal from this mixture. That means FM and AM mixture. This circuit will demodulate. So we have already studied this circuit in AM demodulation process. So by using this circuit, we will get back our message signal from this AM FM mixture. So here we have the response curve of an frequency selective network. So the x-axis of the response curve represents the frequency and y-axis is the output voltage. So this is the waveform we are getting as an output of a tuned circuit. That means the frequency selective network. So here we have already said the resonance frequency of the tuned circuit F0, that must be taken as that must be greater than FC, that means the incoming frequency. So here you see this is the output voltage, so corresponding to the frequency deviation. So we all know we are giving an FM wave here. So FM is the modulation technique in which frequency of the carrier wave will be varied according to the instantaneous amplitude of the message signal. So there must be frequency deviation according to the input signal, that means the message signal. So Fc plus Fd and Fc minus Fd are those frequency deviations. Here is the frequency Fc. So whenever the frequency Fc plus Fd changes, correspondingly there is an amplitude change in the output waveform. Okay, so what we are doing is we are converting linearly frequency deviations into voltage deviation. That means first of all we have an input signal that has only frequency variations, but the amplitude is constant. By giving it to the frequency selective network, according to that frequency deviation there is a change in amplitude because of that tuned circuit. So here F0 will be taken, F0 will be greater than Fc, that incoming signal. So when the frequency is Fc, here we have, this is the Fc, so we have a corresponding voltage level. When the frequency increases, that is Fc plus Fd, there is a change in the amplitude level of the output waveform. Similarly, when the frequency deviates to Fc minus Fd, linearly the amplitude of that output waveform will be decreases. So this is the way, this is the mixture of FM and AM. So this is the output of the frequency selective network. So according to that frequency deviation, there is a deviation in the strength of that input signal. So after that we are giving this signal to the envelope detector circuit, that means diode detector circuit, that is an AM detector circuit. So we have already studied the working of an envelope detector. So one of the simplest envelope detector method is used here, a diode detector is used. So the input of that slope detector is like this, that means it's a mixture of FM and AM waveform, so which has an envelope of, there is a voltage change, amplitude changes here. So the envelope detector, that means AM detector, will detect this envelope, that means the corresponding voltage change will be detected, and that will be the output. That output is our message signal. So this is the way a slope detector works. Here we can see that the slope of this response curve, that slope is corresponds to the change in the voltage level of, that means here the frequency selective network, in the frequency selective network, that frequency selective network will give a mixture of FM and AM wave, that variation in the voltage which is corresponds to the slope of that response curve. That is why we are calling the circuit as a slope detector. So this is the output of the finally we will get the message signal from this FM and AM mixture. The envelope detector will demodulate this envelope, that means the message signal from the FM and AM mixture. So this is the basic circuit of the slope detector, and this is the explanation of frequency selective network and the envelope detector. So here I am explaining the drawbacks of slope detector. So the first one is, it is linear only over a limited frequency range. That means even though the circuit is one of the simplest form of FM demodulators, so if that frequency deviation is maximum, that means if Fc plus Fd and Fc minus Fd is very large, we cannot convert that frequency deviation into voltage effectively. That means there is a non-linearity occurs. That is, so here what we explained, the slope of that response curve and voltage. Here whenever the Fc plus Fd and Fc minus, that frequency deviation is very large, that linearity goes out. That means we cannot find that linearity between that output voltage and frequency deviation. According to that frequency, so there is no such linear voltage change. So the demodulated output and the message signal will not be identical. So that is a major drawback of slope detector. And next is, which is difficult to adjust the primary and secondary windings of the transformer to slightly different frequencies. So we are taking that F0 that must be greater than the incoming signal frequency. So that arrangements, that means the adjustment is slightly, it's a difficult task. So these are the drawbacks of slope detector. Even though the slope detector is simplest circuit, due to this major drawbacks, which is not widely used in FM demodulation process. So this is the explanation of slope detector. Thank you.